Alright guys, this is chapter 2, lesson 4. This is the second video. The first video you solved two triangles, and now you can kind of see here we flipped the page and went to the third triangle. And we're not going to talk through this one. We kind of, as we look through the notes, we said, I think 2 is probably enough. You did this in geometry. But the answers here are for the third one. So if you did the third one on your own, or if you want to try the third one on your own, you can kind of check these answers, and hopefully they're right. But you can kind of see here we've got an angle B is 38.8 degrees. We've figured out side A is 154.2, and then with the Pythagorean theorem, we've got side C is a 198. And so we're going to leave the explanation. If you have questions, certainly ask, but we kind of figured 2 was enough for that. Okay, now we move on to our next topic here. Still chapter 2, section 4, but the next topic within that, and there's really just kind of 2 topics and a little bit of an extension at the end. But what we do now, if you look back at those first 3 examples, they always in the triangle told us an angle. So if you look back at this one, look, they gave us angle A. The previous one, oh, look, they gave us angle A. And the one before, oh, look, they keep giving us angle A. They could have given us any angle. They could have given us angle B also. But they always give us an angle. What's going to happen now is they're not going to give us an angle, other than angle C, which we know is a right angle. But they're not going to give us angle A or angle B. So we need to use the inverse trig functions. And again, you have so much vocabulary, and it's important to keep it straight. Inverse trig functions, this is not to be confused with reciprocals. So let's just look through this for a minute. So we have an inverse function, which is different than a reciprocal function. So the way a trig function normally works is you give an angle, like 34 degrees, and then you apply a trig function to the angle. So you take the sine of 34 degrees, or you take the tangent of 176 degrees, or the cosine of 53 degrees, or you have your chart, which you have memorized with 30, 45, and 60 in it. But it would also works backwards, okay? And backwards means this. We're going to give you the answer. So here's what comes out of the trig function, 0.76. You've got to figure out what goes into the trig function. And you might think, wow, that's kind of a fun guessing game. Now let's play this guessing game, and you might think that. Let's try this for a minute and see how much fun this guessing game is. Clear that out of there. And our guessing game is going to be this problem here. So what sign gives me 0.76? I don't know. What do you want to guess? Let's guess 45 degrees. 0.707. And I know signs of increasing function. Let's put in a bigger angle. How about sine of 50? And hopefully you're thinking, there's got to be a better way to do this. Ooh, 0.766, just a little too big. How about sine of 49 degrees? And if you're thinking there's got to be a better way to do this, you're right, there is. Ooh, 0.754. How about sine of 49.5? We're going to get the better way to do it, don't worry. Ooh, 0.7604. Oh, man, we were so close. How about sine 49 point, instead of 0.5, how about 0.45? And I hope you're enjoying. Oh, we're off by 2. Look at that. 2 10,000ths. Sine of 49.46. What's that give us? Oh, look at that. Even closer, 0.7599. You might be thinking, wow, this is fun. Or you might be thinking, there's got to be a better way than guess and check. And it turns out there is a much better way than guess and check, and these are called the inverse trig functions. So when you're looking for an angle, you use the inverse trig functions. It's written like this: sine inverse, or cosine inverse, or tangent inverse. A second way to write it, which actually I think is more useful sometimes, they can also call this the arc sine, or the arc cosine, or the arc tangent. And your book is going to use both. The first notation here, the sine inverse, or the second notation, the arc sine. All right, and these will go backwards, and these give us the angle. So when you're looking for an angle, these give us the angle for the answer. So they give us an angle, not to be confused with an angel. All right, so they give us an angle for the answer. And again, do not confuse these with reciprocals. The sine inverse has nothing to do with the cosine. They're not even related to each other. I'm sorry, or the cosecant in terms of sine. The reciprocal of sine, cosecant, the sine inverse, they don't even relate to each other. And they often get confused that way. That little -1 notation kind of makes you think reciprocal, but it's not a reciprocal. It's an inverse function, so it's going to give the angle for the answer. Okay, so let's try this on our calculator. And let's go sine inverse, and notice it's right above sine, so I go second sine, and now I'll put in the 0.76, and it's going to give you back the angle. And I bet it'll be close to 49. And look at this, it was 49.46419789. Would have taken us a long time to get that accuracy. So it's nice to have this button in your calculator. And you'll notice it's right above sine, cosine, and tangent. It's sine inverse, cosine inverse, tangent inverse. All right, so let's just practice this a little bit, and then we'll actually apply these to triangles. So what angle has when I take the sine of it, gives me an answer of 0.5. You might be reaching for your calculator. I am. Or you might be thinking, isn't that in my chart? You know, didn't a half come up in the chart? And for what angle is the sine a half? Wasn't that the angle of 30 degrees? I don't know. Let's try the sine inverse of 0.5. And what angle? Well, look at that. It was 30 degrees. Should have known that one. Over here, what angle has a cosine of -0.142? Let's see. Cosine negative. Are you thinking second quadrant? A smart. Second quadrant, the sine's positive, but the cosine's negative. Let's go cosine inverse of -0.142. And it'll give us an angle for an answer. Thinking these don't always come out nice. 98.16 degrees. Let's just write these down so we've got them. Well, yeah, we'll just keep it here for right now. Although that way instead, that'll be a nice record of our answers. Put those guys here, scooch it out a little bit. Yeah, close enough. All right, we have the same thing for tangent. We have the same thing down here for sine. You might think, do we have it for cosecant or secant or cotangent? We do, but we're going to avoid these on triangle. There's no great need to do it on a triangle, a cosecant or a secant or a cotangent. So we'll just stick to the three main functions. Here, let's try the tangent inverse. And I think you've got the hang of this, of 0.784. Got our answer, 38 degrees. And over here, the sine inverse at 2.3. Pretty easy, punching this in your calculator. So what angle, when I take the sine of it, gives me an answer of 2.3. Hopefully you guys are thinking a little bit here, thinking, wait, isn't the range of sine between -1 and 1? You can't take the sine inverse of a number bigger than 1. Sine never. There's no angle where the sine gives you an answer bigger than 1. So, look out for tricks like that too. You can't take inverses of things that don't exist. That was an error. You can't take the inverse of sine. You can't take the sine inverse of 2.3. So, this was an error, and I forgot to write down that first answer. And our error here was that's outside the range of sine. Okay, now let's apply this to triangles. And so what's going to happen is they're going to give you a triangle. They're going to ask you to solve it, same as before, except notice it's triangle ABC. We know angle C is a right angle. But notice now they don't give you any other angles. They give you side B, they give you side C, and no other angles. So let's sketch a little picture of that over here. We've got our right triangle. Here's side C, and here's an A. Here's a B. Side C is angle C. Here side C is 46.3. And then side B is 18.9. All right, we need two angles. We need a side. I'm thinking Pythagorean theorem to get side A. So I'll see if we can fit all this in here. We've got A squared plus B squared equals C squared, Pythagorean theorem. So A squared, I don't know. B squared is 18.9 squared equals C squared 46.3 squared. All right, definitely a calculator question. Let's pop this in, and hopefully I'm not leaving out too much. If I go 46.3, I'll square that. I'll take off the 18.9. That'll be my first part. Get that answer. And I'll take the square root of that. Otherwise, that's way too big of a side, isn't it? So square root of my answer. And what do we come up with? Side A is 42, and since everything else is rounded to the tenths, round this to the tenths, 42.3 for side A. So A is 42.3. Okay, now let's get our two angles. And given a choice here, they gave me this side, I would prefer to use a trig function with those two sides in it. You could use the 42.3. This is the one we calculated. What if we made a mistake in our calculation? Well, if we use that in our next calculation, we're going to have a second mistake. So I would prefer to find angle A, and that's kind of arbitrary, angle A, but I prefer to find angle A using this side and this side, the two given sides. And to do that, it's not hard. That's the adjacent, and that's the hypotenuse. So I'm going to go with the cosine of A. And I've got the adjacent, 18.9, all over 46.3. And guys, look, we are looking for an angle. When you are looking for an angle, what do you use on your calculator? What function, what trig function do you use? Use the inverse trig function. So on this problem, I'm going to take not cosine, but second cosine. So cosine inverse of 18.9 divided by 46.3. Get that answer, and I get an angle of 65.9 degrees. So 65.9 is angle A. So angle A is 65.9 degrees. And guys, once you've got angle A, angle B is very easy to come by. Go 90 minus angle A, so 90 minus 65.9. And angle B is how much? It looks like a 24.1 degrees. All right, we have got this. There's one more problem that's very similar. We'll include that on the third video. If you just want to check your answers on the third video, that would be okay too. But that takes care of our second video.